Hello YouTube. So with the electronics now starting to come together, I thought it was time to take a look at the programming. Let me open the most recent version first. And let me show, this shows all the I2C addresses that are currently connected according to the PI in the boat. I don't believe this actually. There is the I2C is going through a device with 20 as address, which does not show up at the moment, but it did yesterday. Um, and all these addresses here, I don't believe that. I don't believe that. I have no addresses with that device name. I do have a 70. And there are several devices somewhere in these ranges, but not all these devices. That's not good. So if I run this program, let's do that. It says it doesn't know what I2C is bored means. But this programming used to work. What I can try, by the way, is pip install. I have Python 3 installed on this Pi. Update time. Let's see what happens now. It could not find anything. Well, that could make things difficult. So let's put in an hashtag and see what happens now. Still the same reply. There is something with this bus.io. So let's try the same thing, but now with bus.io. And it does the same thing. So that is unfortunate. And I see it also does not recognize, or at least that's how I interpret this here. That it does not recognize it. It's not accessed by Pylance, it says. So let's see what happens. Control C, Control V. If I try and find that one, it doesn't work. Let me see. I did update. Here, I did update board that way. So that is not the issue. I did not make a typo here, it would seem. Oh, wait a second. Adafruit underscore motor kit. Enter. And see what it does now. Nope, no response there either. So this is about the struggle that I get into quite often. By the way, the PCA 9685, wait, that is actually not used here. It's only using this one in this programming. Oh, sorry. Pip install update, Control V. Wait a minute. Almost. There we go. That does work. Let's see what happens now. Same thing. So that did not help at all. Well, let me show you, because as I mentioned before, this does work. I need to update this. And here we see this 0x 40, 41, 42, 43. So if we look at the I2C, that's these four. It says they do show up. One minor thing here is that I actually added two more. Those are not yet connected. One will end up in the drilling tower, and one will end up in the dive area, which is right behind the main superstructure. Those are needed there because a lot of those functions are there physically. There's a crane atop of the dive area. There are two fire monitors. So those are best controlled from this removable section of the boat. So that's why these two addresses are to be added. But if we are working on it right now, let me show how we will do this. We already have three, sorry. We have 4 now and 5. So this is already pre-programmed to be 44 and 45, if I am not mistaken. Let me show. This is the oversight of my addresses. And as you can see here, these are the PWM modules. Uh, I'm Dutch myself, so these kind of documents I do write in Dutch. And these names do not correspond with the programming, but these addresses do. And as you can see, the first one will have actually 16 servos attached. The one midships now only 6, the bow 10, superstructure 12, also some fire monitors, some searchlights, and even the helmsman will have his seat move around on rails. The dive area 15 in total. That includes at least 2 complete davits for lifeboats, um, and some other miscellaneous functions as well. We'll have a check. We'll see about that soon. And 7 functions in the drilling tower. There is also a crane on top there, and several winches. And there's even a stepper motor there, which are named here. So if we look here, this is the overview of all the functions. PWM, mostly at first, main engines, main thrusters as well, bow thrusters. These are these, and where's the other one? Here. These all are the same crane, the big one. There's another smaller crane, and as you can see, it indicates where it is connected. Here you can see stepper 1. This is an indicator from the programming for the stepper motor. And these are the pins, and if I recall correctly, these pin numbers do correspond with whatever function is needed or is actually used. These two, what I will do with the fire pumps, Normally I control the speed of the motor from the nearest PWM module in the same section of the ship. Um, Sorry, let's close that. Um, so these will actually be controlled from the top, from the drilling tower, because PWM 6, as we can see here, is in the drilling tower. There's PWM 6. So these correspond. Um, what I will do most of the time, but not in this case, because the speed control comes from the drilling tower downwards, which means if I remove the drilling tower, which will also be removable, I will actually also remove any control over the motor, which will stop, or at least stay at the speed at which it was. So having said that, this is a little bit different from what I normally do. Here midships, these fire pumps, they end up on top of a deck, which I will very likely keep fixed to the ship. But the fire pumps in the bow, those will get their power from the superstructure, actually through the wheelhouse, because that is removable as well. That way, those pumps cannot pump water up, even if I control the servos. Um, when the superstructure and actually also the part of the superstructure with the fire monitor, so the bridge, the wheelhouse, is not attached. So, oh, sorry, wrong button. Um, so there's that. Um, Let me remove that one. Don't need it. Okay, so there's that. So that is basically what is going to happen with all the corresponding uh, PCBs that it will attach to, pin numbers, voltage, and then I have room to indicate which color of wire I use to control it. Don't use it that often. It's actually more useful for the on-off functions like here, where I already have a couple of cables attached. So I know which wire will do what. And then I keep track of how far I am. Is the wiring connected? A Y is a yes, a B is busy, work in progress. Is it mechanically finished? Is the programming ready? Is it tested? And is it working? So as you can see, nothing is working at the moment. Well, apart from the bow thrusters. They have been tested. Uh, Working is work in progress because I had trouble with the main, with some friction in the bow thrusters, causing them to not be able to get to turn around, basically. So I've tried to fix that, and now I have some leakage in the bow thrusters, but that is another topic for another time. Um, these are the seats for the helmsman, and there will be two seats, so two seats moving. Fire monitors, and this January the ship was in dry dock here in the Netherlands, and I was able to take photos, and I noticed the signs indicating diver in the water, at least on one side, so I suspect, this being a diving support vessel, that that same plate will be on the other side. So we decided, like, hey, it's the main purpose of the ship, so let's have those working as well. It's a very basic function. It will simply turn the plate outboard so that it is visible for everyone to see, or it will turn away in something like a stowed away position. I guess that is what is happening from the photos. So then we have these on-off functions. Um, don't let you be fooled. I mean, this is the longest list already, but this one function uses up 32 pins. I just ordered new PCBs from AliExpress. My own design did not work as intended. I still have some problems selecting the address, and then I found ready-made PCBs, and I was like, well, no way I'm going to keep working on my own design if I can buy it for less than €1. So I ordered those. Those will arrive shortly. Um, what I will do here, there is about 3 times more cabins on this ship than there is interior lighting. So this lighting will be randomized. Um, and I will use, for each light, there will be 3 different cabins being lit up using glass fiber, so that I use as little power as possible for this function and still have it look like it's alive, like um, let's say John is walking into his room. He's reading a book and turns off the light to go to sleep. And the room next door, 50 minutes later, someone comes in, takes a shower, goes out again. Some lights will be permanently on. The mess hall will be a place where anyone will want to come in at any given time of the day. So I will keep the lights on there all day long, all the time. But there will be a button on the touchscreen for this function to turn it on and off. So that is basically, yeah, that it's like lights, smoke generators for when an engine is actually started. This should actually, oh sorry, this should actually be 2. There's 1 for each engine, and then there are sounds. I will have several sound modules in the boat with speakers attached to them, separated throughout the ship. There will be no engine noises because the ship is so well insulated, you will not hear them outside. I've been aboard the ship with the engines running. Actually, I've been inside the superstructure, 1 deck above the engines. There is no way you're going to hear them from outside. So making engine noises is really not realistic. And I think only if there's a door open in the at the rear funnel, there might be engine noises coming through that door, though very few, I suppose. Both the front engine rooms are buried behind all kinds of doors and hallways, so there is no way you're going to hear those engines from outside. So I will not make those sounds. But people talking to each other, uh, some leader giving instructions to the people who are working, will be a very notable noise. People shouting back, especially when things are getting hoisted. One can imagine that someone sees something that is not right, and someone will have quite a lot of noise to make clear that that the person inside the crane house needs to stop the crane, and work needs to be done to make sure that the hoisting can continue. And what also can clearly be heard on deck is the ventilation. those make noise, and those you will hear outside. Actually, I've been like 200 meters away from the ship, and even then, at such a distance, sounds like that can still be heard, albeit not very loud. The foghorn, of course, will make a lot of noise, which will have its own speaker, so that will be very well, very loud, and very well hearable. Then we have inputs. Uh, at what angle are the main thrusters? At what RPM are the engines running? What is the positioning? What is the position of the ship relative to when the sensor for that is powered up? A 9 degrees of freedom IMU fusion sensor. Why an IMU fusion? That makes things a little bit more easier for myself. And as this indicates, it is positioned on a nice flat foundation in the stern of the ship. I still need to work on the programming, and well, I can only test whether it works or not when I have done that. Amidships, there might be a GPS. Um, this is like a gyroscope. It will know where I went from a starting position, but it will not know what that starting position is. There's a second gyroscope in the bow. Why would I want to do that? Very simple. Uh, just be sure that there is no malfunction in one. I mean, if I start at some point, it would be logical that if the ship makes a turn, you would expect that the rear sensor, say we're turning left, one would expect the rear sensor to indicate movement to the right and the bow sensor to the left. Um, so that's basically it. I will also use it to give myself a compass heading and a speed, which will be more accurate than, well, basically anything but GPS. So that's one thing. There will also be, if I can find a way to do it, I mean, the shaft of the bow thruster engine extends like 3 millimeters, something like that, above the engine casing. So mounting anything on that is very difficult. So I want to find a way to make it happen. I'm just not sure how. And I will also want to have some way of knowing that a lifeboat is being charged. So that's a thing. Why is there a 38 there? That doesn't sound good. Well, I'll check that later on. Then there's another thing. Sub-programs. On the on the transmitter there will be two 360-degree rotatable engine levers, throttle levers actually. I want to be able to use either two or only one of them to control the ship. If I'm going to maneuver very much and need bow thrusters, I can well use one free hand, not on a throttle lever, but rather on the bow thruster lever. So I will then switch to either the left or the right joystick for or throttle lever for controlling both the stern thrusters. So there will be three buttons that will tell the boat if it needs to listen to either the left or the right or both joystick inputs. If I select the left one, the programming will be such that I can do anything I like with the right joystick without the ship responding to it. Then we have the cherry on the ice cream. On the cake, I think it was. Dynamic positioning. That's something the real ship, needs to have in such a way that even if an entire engine room is fully ablaze and not operational, the ship can still hold position. Very important for the safety of the divers. So I will use, I will have that function eventually. That's why I have these gyroscopes and two of them. So I know for sure that the response that the engines give, or the propulsion gives, is correct. Random interior lighting, which corresponds to these outputs. Um, then we have the ROV garage door open and closed, and some diver in the water signs. Why am I making a sub-program of that? Oh, that puts on the corresponding navigation lights as well. And the RV garage door open close will also make sure that that both the moon pool doors are closed, while the top one closed and the bottom one open. Otherwise, the RV cannot be lowered into the water, and the crane inside the RV garage will extend outwards so that the ROV will end up inside the moon pool and can be lowered into the water. Prepare for departure. This will do several things. This will actually control the smoke generator here. And where was it? Oh, sorry, that must be over here. These two. But it will also control the cooling water outlets, or cooling water pumps actually, for the engine rooms. What will happen is as follows. There are two generators in each of the three engine rooms. So when I power up the boat and the PI starts working, at least one of the cooling water pumps will start running at very low power, indicating that an harbor generator is running, which will most of the time be the case. As soon as I say prepare the boat, prepare for departure, those cooling water pumps will start to kick in at a higher pace, a little bit above half power and then full power, indicating that that a big diesel generator has been started up and is using cooling water, and then the second one. When the cooling water pump starts running at a higher pace, there will also be a blast of smoke from the exhaust pipe from that engine, indicating that showing that the diesel is actually starting to run. These engines are like 16 years old now. They don't give smoke. You don't, at least you don't see smoke when they are running properly. You only see a bit of smoke when they are started up because they're cold when they are started. So that is what that will do. And that will be times 6 because there are 6 generators in total. These two, and I need to do that over here as well. So there's that. Then we have the transmitter. This all, I need to say that correctly. Um, I'm short a joystick. No, I'm not. No, I'm not. This is good. Um, this is not correct. I need to update this because the bow thrusters will be controlled from here. In the original plan, the last 3 of these joysticks, or sorry, these 3 were to be controlling bow thrusters rather than additional functions. So these will give slightly different commands as well as opposed to these joysticks, because I'll have only 2 letters in the alphabet left and I need 6 for these 3. So there's that. So that now the bow thrusters have moved, I need 2 more here for the 2 bow thrusters. On off, that's the same thing. These are the on off switches inside these joysticks. And these have 2 directions plus the select pin or the push button. Then there is rotary encoder for raising and lowering the radio channel. There's reset, and then I have the touchscreen. And these 3 are the buttons for indicating all the which joystick I use to control the ship, or both, which corresponds to these. And these are not on off. There will be rudder indicators, if you will, but those are powered by the same stepper motor that turn the actual thrusters around. Then there will be a 16:2 LCD screen in the boat, which will have the main menu like this. The ability to set the channel, give show the current command. So if I have this and, for example, I move this joystick, it will show the command generated by that joystick here on the screen in the boat. Info about the boat, RPM of the main engines, the angle of the rudder, of the thruster, RPM of the bow thrusters, power usage in volts from the battery, and amperage from the battery. And it will have a shutdown. Every single time coming from this to this will mean turning the rotary encoder, going if you want to set the menu, this channel, sorry, it's getting late, will mean pushing the button on the rotary encoder, and then it will allow to select the channel, and then pushing the button again will make sure that that selection is used. And that will apply here as well, though this will be on the screen, or this, or this, or this, and that will depend on starting here, going to the right or the left. I need to choose that. With the rotary encoder, we'll switch to here, then here, then here, or the other way around. And shutdown will need confirmation, like Windows asking, do you really want to shut down? So this here is the main Bible of this project. Here, I'm sorry, just when you're recording, your microphone ceases to work. So this is how I build up the commands. Situation 0 is for propulsion. Then these situations will be used for all these joysticks. These 2 are not there anymore. So there's like this. It will give, that MCP 3008 is not in use anymore. So this does not apply. And this is for the on-off switches, for which I use the 7. And here you can see that the other numbers are here as well. Though this should not be here because it is already in use here. And I thought, oh, here it is. So the 1 will actually be used for feedback back to the transmitter. So this will not come from the transmitter, but rather from the boat. 2 for PWM controlled from the touchscreen rather than a joystick. 6 for PWM function, which is controlled as an on-off, like those garage doors for the ROV hangar. 7 on-off, and 8 on-off feedback to the transmitter. Address I showed, PWM functions. Here you can see which function goes to which address. I2C address this is, which is the name that I use here in Excel for the device, and this is the command that it can have. And what you can see here is 0 to 255, that is PWM range. Cooling water pumps are controlled by that on-off function, basically indicating preparing for departure or shutting down the ship. Here is an odd thing. These are the stepper motors for turning the ship. These go from 0 to 3600. Why this value? It is basically, I did not want to use decimal numbers, and the accuracy of these stepper motors is about 1/10 of a degree. So I decided that I would simply do the degree, or sorry, the heading in degrees times 10, so I can use the decimal accuracy, but not have a decimal in my command. I don't know if this would cause a problem if I would use the decimal, but I'm not going to. And these will need to be the same. No, not. No, these do not need to be the same, even though these are stepper motors. The reason why is very simple. These are controlled by joystick and actually are more like a speed control for the stepper motor. And these give an actual heading because the control is 360 degrees rotatable. It's measured by a magnetic Hall sensor, so there's really no limit to it, and the stepper motor also is limitless in its rotation. So I don't need to worry about anything getting stuck by using it this way, and making it easier and more understandable for myself. The same applies here. The first letter indicates what its function is. The second is from indicates which joystick or input is controlling it. Yes, the A, for example, is used double. That is no issue because the 0 cannot be used for anything that the other joysticks can be used for. So there's no issue there. And anything using the 0 really has only one function in total, so this also does not provide any problems whatsoever. And I kept the room for if I extend the list in any way, though these kinds of information still need to be filled in when the time comes. I use this room to indicate how much I am using every joystick in which situation, A, B, C, D, etc. But at some point there were so many functions having been added that list became outdated, and I sketched it on paper, so I'm fairly sure that it will work just fine. I did the same thing for the on-off functions, which all start with a 7. Here the I2C addresses. I could not separate these numbers. Perhaps someone knows how to do that. I'm glad to hear that. So this 0 after the 4 should actually does not belong to the 24. It's 0x24, 0x25, and 0x26. Inputs here with the corresponding code. Um, Subprograms indicating which goes where. Still need to fill in this list. So then I decided, like, hey, I'm going to use these kind of stackers with these connectors. I need to know which goes where. So I made this screenshot and indicated which connectors are where. And actually at 1 there are 2. There's one here, there's one here. Though I might change this out for a 25 pin connector, which I found on Amazon recently, because the drilling tower actually needs 90 connectors. So there's that, and this connector is already there, and this connector as well, and wires are connected. I simply need to retrace my steps and see what connector does what, and then fill this in. This is the power distribution. It's quite basic actually. The main fuse. There's not really anything only behind this fuse. This one goes to this, this, and this. So yeah, it's everything is behind that fuse. If sorry, these 3 are behind it. So the stern propulsion in the stern and in the bow are not fused through this one. That is a limitation of the fuse box that I used. And this group 4, the functions in the bow and function in the stern, have their own switch. So I can drive the ship with groups 1, 2, 3, and 5 for the pi turned on with the main switch, and not have the separate functions on saving power while sailing that way. It is a manually operated switch, so if I decide that I want to use the functions like the crane and stuff like either of the cranes, I need to get the boat back and then do that. Turn that switches on. A whole list of the cost. I'm not going into that right now. Color coding for the transmitter. This is the pinout for the pi. Very important to keep proper track of that. Just to make things easy, these are all the pin functions on the pi. And on the NRF transceiver that I use, 2.4 GHz. This list is actually up to date at the moment. TCA 9548A, that is a I2C multiplexer. So it uses only one address and it connects 8 I2C devices. And I need actually 9 of those. And this one I need to change out because of the decision made today with the AliExpress part, and this one as well. Um, this will be this, and this without that will be the same in every single extension part I make for every single ship model that I will build. Because these addresses are read out by the programming, which is... Do I have time for this? No. I have a programming somewhere. Uh, yeah, this is the one. I still need to rework this because these MCP3 008s are not in use anymore. So this needs to be rebuilt, but this is basically what I was using to work on the program for the transmitter, but not in use anymore. So there's that. And there's the same thing for the boat, though this is not needed anymore. Um, Here's the rotary encoder. Power, which is now done differently, so delete. I now have a Geekworm power supply PCB, which handles the power quite well and has its own power input and its own power switch. So I don't need to worry about shutting down or resetting the Pi if need be. I2C, SPI for the transceiver, rotary encoder, and this is also for the SPI. Same image here as we saw here, this one. So that things are as clear as can be. So I'm going to call it a day now. Oh, this was a recording of over 47 minutes now. Uh, so this is basically going on the background. As you can see, I'm struggling with this, and my father does have the ability to help me sometimes, though he is more of a Python programmer for data handling rather than controlling devices. So his understanding of Python is much better than mine, but still uh, we need each other to learn this, to get it to work. Um, what I do want to add, which may be very important in giving anything like any advice, um, I kept this Pi up and running all night actually on power supply from the lighting grid in the house. Um, the reason for this is that when I shut down the Pi in the boat, I cannot reboot it. I cannot get it started again for hours, I think. I don't know why, but it simply will not boot, uh, even if I try it again and again. In the for the Pi in the transmitter, that is a Pi 3 Model A. In the boat, I have a Pi 4. But then the full board with the 4 USB ports rather than the one in the transmitter for space saving purposes. Um, the Pi 3 for in the transmitter, it breaks down, it crashes whenever I hit the save button. Don't know why, but it does. So there's that. If any of you have any advice, I'd really like to hear it because I really want to get this fixed and getting over with. Um, if no one can help, I will most likely either start by copying everything that is on those disks, all this here, oh sorry, and then start all over again, completely install it completely again, all over again, for both of them. If that does not help, I will most likely buy myself two new Pi 4s. I will not go for the Pi 5. It is faster, but it also uses more power, and I'm limited by my battery capacity. So I really don't want a Pi 5. The 4 is powerful enough for me. So there's that. So goodbye for now, and I see you the next time. Bye bye.